Welcome student. Today we will learn about the queue. So what is the queue? Queue is basically a linear data structure that work on the principle of first in, first out. So these are the contents of our today lectures in which we learn introduction to linear queue, insertion, algorithm of linear queue, deletion algorithm of linear queue, introduction to circular queue, deletion algorithm of circular queue, insertion operation of the circular queue, application of the circular queue. Now, what is the queue? As we know, basically queue is also a real life example, like we can see like the passengers standing for taking a ticket on the ticket window. That is the example of queue. So queue is a linear data structure that work on the principle of FIFO, first in, first out. In the queue, insertion and deletions are performed on different ends. The end at which we perform the insertion is known as a font, and the end at which we insert the element, delete the element is known font, and the end at which we insert is known as a real. So there are two types of the variables mostly used in the queue, font and real. So font is basically a variable that denotes the end at which we perform the deletion or removing operations. In other words, we can say that font variable is basically used to denote the element to be deleted or removed. Second variable is a real variable, and this is variable basically denote the end at which we perform the insertion operations called as a real. This is the block diagram of a queue, and basically a queue can be represented like as an array, but there is some logical difference between queue and array. So here we mention this is a queue and these are the subscript of the queue. This end is known as a font because the operation of deletion is performed here. Due to this variable denote the deletion operations, and this end is known as a real, and any element to be inserted in the queue will inserted at the real end. For example, we take here when our queue is empty, then index value of font and real is basically denoted by -1. It means if value of font and real is simultaneously -1, then we can say our stack is empty. And when we insert any element, or we can say we first time insert the any element in queue, then value of index value of font and real is increased by 1, and that become 0. Font is always denote the element to be removed, and real is always denote the element to be inserted. Okay. So we can say here our starting element is 10. So font denote the index 0, and our last element is 25, and real denote is corresponding index 5. So we can say when our stack is full, then font element denote the first element and real denote the last element. When we perform the deletion operation, then font value is increased one by one. Now we can take this example here. When I remove element 10, then font value goes index 1. When I remove the value 7 at index 1, then font goes the index 2. So this process become continue, and when font equals to become real, or we other words we can say font equals to real, it means that denote that in our queue there is only single element. So using this example, we can observe that after removing two elements, the font value is 2 and rear index value is 5. Now we see this example how we perform the insertion operation in a queue. Here we observe that at first step our queue is completely empty. So our queue is empty, then value of font and rear, F denotes the font and R denote the rear, is -1. When we start to insert the elements, then value of F increase by 1. So -1 plus 1, that value of font becomes 0 and it denotes the first element that is just inserted in the queue. The value of font is held till it is not removed. Now we insert new elements. Here is 20. So value of rear is increased by 1 and at this increase index we insert the new value 20. This process become continue till we can't get the full queue. Now we consider here how we perform the deletion operation in the queue. In this diagram we observe that element 10 and 20 are filled in our queue. So when I have to remove or delete any element from the queue, then I always need to perform this operation from the font end of queue. So when I will remove 10, the value of font will be increased by 1 and that's index value of F become 1. Now here we can say value of F and R is same. In other words, we can say when value of F equals to R, then we can say that there is only one element in our queue. Now using this concept, we perform the insertion algorithm in a queue. So it is when we perform the insertion operation in a queue, it is very necessary to examine that we have to check that our queue is overflow or not. If our queue is overflow, then we can't perform the insertion operation. So to check this, we make a process. Process name is queue insertion and we take these elements. Queue is our queue and font is variable that denote the element to be deleted. Rear, the variable that denote the element to be inserted. Max denote the size of the queue and element is that element which we have to insert in queue. So first I have to check for the overflow. To check the overflow, I have to check that rear equals to max minus 1. It means if we get the index value of rear is the last index of the queue, then we can say that our queue is overflow and such type of condition we have to return. Now step 2, if font equals to -1 and rear equals to -1, it means if we found the index value of font and value of rear is -1, then we can say that our stack is empty, and in such conditions first I have to set the value of font and rear to 0 and after setting this we can go in step 3rd and we can insert the elements. If the value of font and rear is not -1, then I have to set rear equals to rear plus 1 and I will insert this value and then exit from the program. Next algorithm is deleting element from queue. So we make a processor queue deletion. Here is queue deletion and we take Q, font, rear, max and value. So here I have to check first that underflow condition, because if our queue is empty then we cannot perform the deletion operation. So first I have to check the condition for underflow. So condition for underflow is that if our font equals to -1 and font is greater than rear, it means font equals to rear plus 1, then such conditions we have to send a message that our stack is underflow and we have to return from here. Else, if this condition is not true, then we will go in else part and we will set value is assigned with the contents of Q font, and after removing this Q font value, I have to increase the index value of the font and then finish off, and our program will simple or linear queue. Basically, a queue in which data are represented in a sequential way is known as a linear or simple queue. So there are some drawbacks in the simple queue or generally queue. Due to this drawback, we have to follow the circular queue. So there are mentioned some drawbacks. First drawback is that when real variable gets its max index and some element from font variable index are removed, then we cannot fill relieved spaces. It means when we delete the element from the font and these when we delete these cells becomes relieved, and this relieved cell is not filled back because if our rear index is the last index. So it is used for the limited data processing. So to avoid this drawbacks, we use basically circular queue. What is the circular queue? A queue with no ends is known as a circular queue, and after the queue reach its last index, it start again from the first. So a queue with no ends, after queue reach its last index, it starts again from the first, is known as a circular queue. In the circular queue, once the queue is full, the first element of the queue become the rearmost element if and only if the font has been forwarded. Otherwise, it will be overflow condition. So we can see here this example. Our font denote this index, it means font denote index 0, and when the elements are inserted, the value of rear is increased and reach here, and if we again put some values, the rear will go here. So when rearmost element will jump on the font if our font value will go forwarded to the next cell. Otherwise, this when rear reach here, then this is the condition of the overflow. Now using this diagram, we can consider how we insert and delete in a circular queue. This diagram denotes our circular queue is completely empty. So when value of rear and value of font equals to 0, then we can say that our circular queue is completely empty. Now we insert element 10 here. So when I insert the element 10, then I have to set the value of rear and front by 1, or in other words, we can say inserting the first element, the value of rear and font is increased by 1. Now after that, I insert the new element 50, then the font will not change its index position, but real will change its index position. So every new inserted element the rear will change its index value, and when we remove any element in this condition, the font will change its index value. Example we can see here. We remove here index 10 value store and index 1, that is the 10, and I remove the 10, then font goes the index 2 and denote the element 50. So we can say that in every new inserted value, the value of rear is increased by 1, and for any deleted element the value of font is increased by 1. So in circular queue, we also performs two operations: insertion operation and deletion operation. That is the basic operation in a queue. So to perform the insertion operation, we call a procedure insertion circular queue, and we take circular queue, font variable, rear variable, item, and denote the number of the element, or we also can say that and denote the capacity of queue, circular queue. It means how many elements we can insert in circular queue. So n is also denote the maximum capacity of storing a circular queue. Now when we perform the insertion operation, so it is necessary to check the overflow condition. So to check the overflow condition, we have to check the values of variable font and variable rear. If variable font value is 1 and variable rear value is n, or font equals to rear plus 1, in such case we can say that our circular queue is full or overflow, so we can't perform the insertion operation and we have to return from here. Now in step 2, if variable font value is 0 and rear value is 0, in such a case we can find that our stack is empty, and when our stack is empty, then we can perform the insertion operation. So in condition of font 0 and rear 0, first I have to set the value of font by 1. It means for font will set at the index first, and after setting this we have to go step 4. It means I have to increase the value of rear by 1. Now in step 3, if our rear is at the last index of a circular queue, in such cases first I have to set the rear by 1 and then I have to go on step 5. And step 4 is used to increase values of rear by 1 for every new inserted element, and last step denote the finish of our algorithm. Next algorithm is deletion algorithm of a circular queue. So to perform the deletion operation, we call a deletion circular procedure, in which we include circular queue, variable font rear and font, and item and size of circular queue elements, that is also denote the maximum size of the circular queue. So when to perform the deletion operation, it is necessary to check the underflow or empty condition of a circular queue, because if our circular queue is empty, then we cannot perform the deletion operations in the circular queue. So in first step, we check if font value is 0. In such case, we can say that our queue is underflow or empty, and if our queue is underflow or empty, then such situation we cannot perform the deletion operation and we have to return from here. Now step 2, if our circular queue is not empty, then first I have to take the element from the circular queue having the font index, because the deletion is performed from the font index variable value or font value. So circular queue font value is assigned in item, and after that we can delete the item. Next, step 3 is used to find the condition if our font equals to last index. In such condition, I have to set the font index by 1, and setting this index I have to return from here. Step 4 denote that if our font and rear are both same position, it means there is no any element. In such a condition, I have to set the font value 0 and rear value 0, and setting the font value 0 and rear value 0 means our circular queue is empty, and in this condition we have to return from here. In step 5, if our stack is not empty, then I have to increase the value of font by 1 to access the next element, and after that we have to return from it. Now our next topic is what are the applications of circular queue. So in technical education, the circular queue have the very effective applications like as a memory management. In memory manager, circular is used to manage memory, or in processing schedulings to process the different it is used in a different type of the process schedulings. SCP use a queue to schedule the process like as a first count according to the principle of the first come first serve. So for this purpose we use basically queues, and there are some other application like as a traffic systems. Queues are also used in the traffic systems management. So today our lectures is finished here. In next lecture we will consider priority. Thanks.